Guys, good morning. This is Miss DK again. I hope you're having a good day so far. So what I'm going to be showing you right now is how to do um, the other gas law, which in this case is the ideal gas law. All right. So far, what you've learned is that you have two conditions for pressure, volume, and temperature. All right. And so that's the reason why you were using this P1 V1 over T1 equals P2 V2 over T2. All right. So you have those ones right here and twos because you have initial and final conditions. All right. Okay. So this is what you use. All right. If you have two two values of one thing, what does that mean? It means you have two pressures or two volumes or two temperatures. All right. And when we use this formula, we just have to make sure that the units are consistent. What does that mean? That if you have volume, for example, it could be in milliliters or liters. Okay. So it doesn't matter which unit you have as long as the volume units are the same. So if you have V1 as milliliters, V2 must be in milliliters as well. The same goes with P. It could be ATM, torr, mmHg, or kPa. All right. However, for temperature, it must always be in kelvins. All right. So we know that. Sorry about that. Temperature must be in kelvins. All right. And that's when we add 273 to the Celsius reading. Okay. All right. So that's how you do Boyle's, Charles, and combined gas laws. Okay. All right. So if you haven't finished those worksheets, please try to finish them today. All right. During this time period. Okay. All right. So let's do the ideal gas law. All right. So in ideal gas law, we now have only one value for each pressure, volume, and temperature. All right. Only one value for each one. Okay. So that's how you would know if you're using um, the ideal gas law. The ideal gas law is has a formula. PV is equal to nRT. The way to remember that is PEV NERT. Okay, I say it again. PEV NERT. Okay, so PEV NERT. P stands for pressure. V stands for volume. All right. Here, look at the units. You must have it in atmospheres for pressure, liters in volume, and moles is the N. Now we have moles, all right? So again, how do you get the moles? If you're given with grams, just convert it to moles, right? R is a constant. It's always this. All right? Do you have to memorize all of these? No, as long as you change those units into their standard units, again, which are ATM, liters, moles. All right. And of course, we know this already. The temperature must always be in Kelvin temperature, which means you always have to add 273 to your Celsius reading. Okay. All right. So let me show you how to do these problems for ideal gas law. So for number one, it says, how many moles of oxygen? Again, to find out what the question is asking you to do is to look at the words after the word how, what, or action word, right? So here in this case, you are looking for moles of oxygen. And going back to this formula right here, the symbol for moles is N. All right. So we're looking for N, and it says here, will occupy a volume of 2.5 liters. Okay, so that's your volume right there at 1.2 atmosphere, ATM. So it did not say that is pressure. However, that's the unit for pressure. So you have to do that as P. All right. At 25 degrees Celsius, that's your temperature. But it has to be in Kelvin. So you add 273 to it. It will become 298 kelvins. Notice that you don't have any other values for either V, P, or T. And that's actually a hint that you're not using the previous formula of P1 V1 over T1 equals P2 V2 over T2, because you're only given one thing of those quantities. Okay, you're only given with one V, one pressure, and one temperature. So that means it calls for Pevner. All right. Okay. So since we're looking for N, all right, we must have all of these: P, V, R, and T. All right. Do we have P? Yes, it's right there. Do we have V? Yes, it is there. Do we have T? Yes, it's 298 kelvins. Do we have R? That is a constant. It's always 0.0821. And that's what we're looking for, N, right? And that's actually how you do it in chemistry. Every time you're using a formula, there is only one thing that is unknown. If it's not, then find hard enough to find it in the problem, right? All the values must be there except for the one that you're looking for. Since in this case we're looking for N, which is the number of moles, everything must be provided. Okay? If it's not in the problem, probably it's a constant like R. It's always 0.0821. So before you plug in the numbers, make sure that they are in standard units. Okay? The reason is that your constant has all the standard units. All right? Those standard units will help cancel out the units that you have there so that you can only have the unit that you're looking for. In this case, we're looking for moles. So after you change them all to standard units, you will end up with moles. All right? So now we know that they are all in standard units, excuse me. So we're now going to plug in the numbers. So pressure is 1.2. The volume is 2.5. The N is not that what we're looking. That's what we're looking for. That is X. R is 0.0821, and temperature is 298. All right. You do all the math there and divide both sides by the number next to X. All right. So let me grab a calculator. So this must be 1.2 times 2.5, and that gives me 3. 1.2. All right, so that is the 3. All right, and now we'll divide that by 0.0821 times 298, and divided that by 244.658, and looking at the sig figs, so that would be 2 sig figs. So my answer would be 0.012 mole. Right? So again, what we did here is we simply plug in the numbers. They must be in standard units, like pressure must be in ATM, volume must be in liters, and temperature must be in kelvins. We're looking for N, and so we plug in all the numbers and solve for what is missing. All right, now let's look at number 2. It says what volume? Well, 2.0 moles of nitrogen. So now you're given with N, you're looking for volume, okay, which has units of liters. Of nitrogen occupied 720 torr. Torr is another unit for pressure, but it must be changed to ATM, all right, at 20 degrees Celsius, so that's 293 kelvins, all right? Now, if you remember pressure units, up here, all right, you must have, so all of them is equal to 7, so this will all be related to 1 ATM. They're equal to 1 ATM. 760 torr, 760 millimeters mercury, or 101.3 kPa. All right, so how do you use that? So every time you have anything that is not ATM, then divide that by that number equal to ATM. So for example, 720 torr, there's 760 torr in 1 ATM. Simply divide 720 by 760. Or let's say this is 720 mmHg, Again, there are 760 in one ATM, so you simply divide 720 by 760. Now, if this happened to be 720 kPa, then you would divide 720 by 101.3. Okay? I hope that makes sense. All right, so pressure has to always be in ATM. It has to be in ATM. Pressure must be in ATM. All right, so since this is in torr, I have to divide 720 by 760, and I will get 0.947. However, there's only two sig figs, so I will do 0.95 ATM. All right, so I have to look. Everything must be in standard units: ATM, kelvins, moles, perfect. So now I'm going to be using PEVNERT. PV is equal to nRT, right? So pressure is 0.95. So I'm plugging in the numbers now. Volume, that is a noun. That's what we're looking for. And the unit for volume must be in liters once you solve it. N is 2.0. And then 0.0821 is your R. And temperature is 293. Yes. And temperature must be 293. Now you do your math, right? Solve for X. You'll get X is equal to, or that is your volume, because we're looking for that, right? You multiply 2.0 by 0.0821 by 293, and you'll get that number, which is 48.1106. And you divide that by 0.95, and that must be 51 liters, because I want two significant figures. All right? So that's all to it, okay? So I hope you understand, all right? And I'll see you next class. Have a great day. Bye-bye.